So I guess the Monty Python phrase, "now for something completely different," comes to mind. I'm the, I think I'm the token political scientist on the program. And I'm happy to...
Eric was. You're not a token.
Oh, well. I'm happy to be in Eric's company. You're right.
Happy to be labeled a political scientist.
I don't know if I believe that. So, so this is joint work with Tassos Kalandrakis, who's a colleague of mine in political science at University of Rochester. I want to start off with a couple. It seems like I'm doing this more often now. I'm starting off with disclaimers at the beginning of my talks. So the first one is that this is actually it's going to be really very applied political mechanism design. The project involves a lot of computation, and I just have to give Tassos full credit for that. I tried to help at first, and then it became apparent that he knew infinitely more than I did about it, and so it was pointless. So all the computational aspects of this project are due to Tassos. I wanted to, and so I also wanted to say that this talk is going to be primarily conceptual. We have an ongoing research project, and I'll show you where we are in that, but we're not all the way yet, and we actually we don't have a whole lot of mechanism design actually to talk about. But I'll sort of tell you the perspective that we take on these things, and then give you some preliminary results. But so, I mean, mechanism design, I think political mechanism design is an especially rich area to ask design questions, right? I mean, because these mechanisms are, you know, they're well known. They're documented in constitutions and rules of procedure, and you know, we actually do run into applied questions about, you know, what kind of political systems should we create? You know, when we're constructing democracies in Eastern Europe and reconstructing the government in Iraq. I mean, these questions come up all the time, and you know, it'd be nice to have a more well-informed approach to these problems. That's not a good design, is it?
Now you can just press.
That wasn't a very long leg.
Keep using.
Okay. Well,
If it comes back up again, talk faster.
yeah.
Here it comes up.
You think so? I'm not convinced.
There's got to be a setting.
Well, something's a little bit better. But I don't know if it's the projector or the computer or what.
No, it's the computer.
Think so?
It's the computer.
Computer's shutting down when you're not using it.
It's going to sleep too fast. But then
It's
it
going to
doesn't.
sleep when you're.
But then the projector doesn't wake up.
It's going to sleep too quickly, basically.
Should we try this?
So if you have a pointing device.
I don't know. But maybe not yet.
I don't see why they can't. I mean, I've never seen one.
Okay, John, why don't we start?
There we go. Okay.
Yeah.
Now, where was I? I think that I had made my disclaimers, and I was saying that that political mechanism design is a rich framework to ask mechanism design questions in. You know, these questions are coming up in the real world, and you know, so we can think about, you know, there's all sorts of different ways we can think of reforming political systems. What are the effects of these changes? You know, and in particular, you know, you might have some objective of promoting democratic transition or economic development, or you might just have some notion of welfare that you want to maximize. What is the best political system? Right? These are huge questions, and we're not. I mean, this probably isn't a surprise, but we're not going to be asking such questions with such huge scope. We're going to have to narrow things down a bit. In particular, we'll be focusing on U.S. politics. Actually, we'll be thinking about national politics rather than sort of distributive or district-specific politics. You know, we'll be asking. We will be, because we haven't really answered these yet, but we'll be asking fairly specific questions about institutional modifications, such as, you know, what would happen if we removed the veto, the presidential veto in the U.S.? What would happen if we removed the veto override so that a veto was absolute? You could consider playing with voting rules in the House or the Senate. You could consider, you know, what would, you know, right now we have a bicameral system, bicameral legislative branch with the House and Senate. Well, what would happen if we had a unicameral legislature instead? What's the effect of a bicameral legislature? There's, you know, all sorts of questions. You know, also we have staggered Senate elections, so in any election year, only a third of the senators are up for election. We have, you know, we have a 2-period term limit for the president. We have legislative elections every 2 years, so there's a midterm election where the president is not up for election. But, you know, what would happen if we had them every 4 years? I mean, there's so many questions you can ask like that. But they're fairly specific questions. We're not really taking this general mechanism design viewpoint where we want to sort of maximize welfare over all possible mechanisms. We're interested in kind of a restricted subset. So I'll talk more about some distinguishing aspects of the approach, but just up front, I'll mention that I mean, one way that our approach is a little different from the usual is that we are explicitly accounting for the fact that government and policymaking takes place over time. It's not just a one-shot thing. Another feature is that there is a mechanism currently in place, right? We have a governmental system. We can observe data, right, that's generated by the history of play. And this actually opens the possibility of estimating environmental parameters that are unobserved to the planner, that is us. And so these are features that are not in the usual sort of mechanism design framework, but they're important for what we're doing. So no one else has put up the Mount Rider diagram today, so I thought I would do that. What? You put up the equation. See, I'm minimizing the equations here. But so the idea, of course, is that there are some environmental parameters that are unobserved by the social planner. But if he knew what those parameters were, he would like a particular outcome, okay? And so that actually is this, so those objectives can be described by a social choice function. And the problem is to design a mechanism, right? So you give the agents a set of messages that they can send. You pick an outcome function that will map those messages into outcomes. And then you let the players play this. And the idea here is that if they're playing equilibrium strategies, those equilibrium strategies, first of all, note, since the planner doesn't see the parameters, this outcome function can't depend on the parameters. But if the agents are using equilibrium strategies, their strategies will depend on these parameters. And ideally, you make this diagram commute, okay? So that the planner ends up getting the outcomes he wants for all parameters, okay? So in the standard framework, the agents know these parameters, maybe their preferences or beliefs over types or that sort of thing. The planner does not observe those parameters, and the planner wants to design a mechanism that will produce the right outcomes for a large domain of parameters. And lastly, the mechanism, we usually think of as just being a one-shot thing. There is actually, I mean, you could this is a very general schematic, and so there could be some dynamic structure in these things. But I thought it would be kind of fun to bring that structure. Okay, so planner's objective might be to maximize expected social welfare with respect to this inquiry, or in fact, what we're going to do is try to get a point estimate of these parameters and use that. But I thought it'd be fun to bring out the dynamic structure in what we're doing. So the way I think of it is there's some set of parameters. Implicitly, we're assuming these parameters are not changing over time, and they're going to be preferences and some other things. And what happens is, well, in general, you could think of there being an infinite number of periods. In each period, there's some mechanism. So in period 1, the outcome function is G1. In equilibrium, players are for M1, which will give you an outcome. And then that outcome, you can imagine feeding into the mechanism in the second period. Like so, right? So in period t minus 1, suppose the outcome is xt minus 1. You can imagine in period t, players send their messages, and the outcome is a function of messages and the previous outcome, right? You can imagine this. In fact, you can imagine more general dependence here. I mean, there's no reason why this outcome function couldn't depend on the entire history of outcomes and messages. But this is just to get the idea that dynamics are playing a role here.
And do you imagine that agents understand that what they do now will affect what mechanisms they play in the future?
Are you asking if the agents are anticipating the institutional designer's choices?
Yeah.
No. We're imagining. Well, let me get to one more picture, and I'll come back. Okay, so this is kind of a broad view of dynamic mechanism design. And what we're doing is we're looking at political mechanism design. So,
can I go? Can I just follow up Eric's question? Because you could imagine if the mechanism designer can make a commitment in priority, then this is you can write this out in a way that's equivalent to one. That's just a long, extensive form, one-shot game.
Mm-hmm.
Okay. So the issue about whether the mechanism designer is coming in and entering in a proactive way along the path is a sort of in a kind of a sub-game perfect way, is important. And you're assuming they come in a proactive way, or the rules of the game are all known a priori.
Well, let me go to this here. So, if I could take a few minutes to get to these questions.
Put it on. Just go on, and I'll get back to it.
But if I don't get to it, please remind me. But I'll try to. So, but we're looking at political mechanism design here, and so, the mechanisms here, they're not too weird in reality, right? I mean, political mechanisms tend to involve voting and whatnot. And now we're not going to try to explain why that is. That's kind of outside what we're doing. But we're interested in kind of a class of mechanisms that have kind of the usual political kind of properties. In particular, I think it makes sense that this outcome function be stationary, so that it's not varying with past outcomes in a weird way. I mean, there's no reason why whether a bill passes today should depend on how people voted last year, that sort of thing. So let's think about a stationary mechanism here. And in fact, for what we're going to do, tractability does, we're trying to be applied here, and tractability plays an important role. And we're actually going to be considering, we're going to be assuming that agents are using stationary strategies, okay? Okay, so here we have, so some parameters are realized. The first period, choices are made. The outcome is x1. In the next period, choices are made, the outcome is going to be x2, which depends on the choices in the second period and the previous outcome. That's kind of the structure that we're thinking of. And we're just about to get to these questions now. So, as I said, though, when we're thinking about sort of U.S. political mechanisms, there's a mechanism in place, let's say for T periods, and I'm imagining that this mechanism is known to the agents. They're playing this mechanism, and then as mechanism designers, we're going to come in and say, in period T plus 1, I guess, we're going to say now the mechanism is G prime, and then let them play. And in answer to Eric's question, when these guys are playing this game, they're not anticipating us coming in and changing this mechanism. And I'm taking the sort of the usual view of the social planners being outside the system, and I'm just going to, surprise everyone with a new mechanism. Okay. And actually, no one in the real world cares what I'm doing, so that's probably valid. So,
but to take a variant of my question, when I'm playing in period 3, for example, do I take account of the fact that that the choice that comes out of period 3 will affect the game in period 4?
Absolutely, yeah.
So okay.
Yeah.
So players are not myopic.
Players are not myopic at all. They're farsighted, but I just wanted to emphasize that when they're playing this game, they think this game is going to continue forever, and they don't know that we're going to surprise them with a new mechanism.
Okay.
That's the sense in which they are surprised. Okay, Don? Okay, and so we observe the mechanism that's in place. We can read the Constitution if we want to, and rules of procedure. We can observe these messages here. We think of them as votes and vetoes and that sort of thing. I suppose we can actually read legislation to see what political outcomes are, but we're not going to try to do that. We're not going to try to map real-world legislation into our model. So we're just going to say we don't observe these outcomes, actually. All right, and so what we want to do is, on the basis of these observations, this historical data, we want to estimate the parameters that are determining play. We'll also have to estimate a distribution over the outcome in period T, which is unobserved. And then we can consider, making some institutional changes. And given the point estimate of these parameters and the distribution over the outcome in period T, there's a distribution of outcomes that ensue. And we can ask, well, what maximizes the welfare of the voter, for example? And actually, in our setup, we're going to assume kind of a unitary voter. And I mean, there's some simplifications involved here. In general, obviously, there's more than one voter, and it might not be clear what objective function to use, but that's for the future. Okay, so that's kind of the overview of the structure of our problem. The problem that we're looking at is, well, first of all, describing that existing mechanism is essentially a modeling problem, and estimating these parameters is really just an empirical problem. And so I think that there really is. I used to think of implementation theory as being completely different from modeling, and now I'm kind of seeing that they are tied together. Some distinguishing features of what we're doing, I already mentioned that we consider politics taking place over time. There's an existing mechanism in place with partially observed historical data. We can estimate parameters. And when I say political constraints here, I mean we're not going to be thinking about abstract mechanisms where people are reporting integers and whatnot. We're going to be thinking about, well, for one thing, stationarity, which I mentioned. It's in designing a constitution. I think there's limited scope for using transfers and all that. And we're really going to be looking at specific kinds of institutional changes. And then I mentioned tractability constraints as well. So those are, this is my sort of broad take on political mechanism design. It's a little bit different from the usual framework. And I just threw out this comment at the end here that it seems to me that the problem of designing regulation for an existing industry has some of the same features. And I did some Google searches, and I didn't really turn up much on this. There's a literature on estimating parameters in auction settings, but it seemed like it was kind of removed from what we're doing. Now, since we're essentially proposing structural estimation of these unobserved parameters, you want to be using a model that's pretty realistic if you can. And so we are considering a model of U.S. politics that has some features that you would want. It's not the it's not the last model that will ever be written, but we're considering a model with a bicameral legislature and an executive veto. Policy making takes place over time, and the status quo evolves over time. It's a multi-dimensional model, so if there's more than one dimension, I can say multi, right? It's 2 dimensions. We have endogenous elections. As I mentioned, we have a kind of unitary voter in this model. That's the model we're going to use to estimate these parameters. And I already mentioned some of the institutional questions we'll be asking. And then there's a long list of things we don't consider. Private information, self-enforceability of a constitution. I mean, that's a big question, and we're not even going to worry about that. But there's that's only a partial list, of course. I mean, we're doing what we can. Okay, so in time, as I mentioned, so we have a model of 2 chambers, House and a Senate, and a president. In this model, it's an infinite horizon model, and we're going to imagine that there's 6 types of politicians. You're either in the House, Senate, or you're president, and there's 2 parties. Okay, so we assume a countably infinite pool of each type. Okay, and when a politician's kicked out of office, we assume he's never going to be in office again. But they do still care about policy, so they don't just disappear. As I mentioned, we have a swing voter, we call him, who sort of helps determine.
The comment about countable infinity of politicians, that's an empirical fact, isn't it?
Well, these are potential politicians, I guess I should say, but right, and it's an infinite horizon model, and we're going to be thinking about finite policy space for the purpose of estimation. The timing of the model is, well, the model's, it's kind of complicated. Okay, so in each period, there's 2 stages. There's an electoral stage, where the voter makes a decision and determines the composition of the government, and then there's a policy-making stage. And the model uses some noise. This is to, in this kind of work, you need some noise in here because you don't want to end up with a likelihood that's just always 0, right? You need to be able to maximize it in a meaningful way. And so what we have is there's state variables in this game that evolve as the game is played. There's the current policy, which determines the status quo in the next period. And then there's also something we call an electoral state, and there's a political state. The electoral state, it summarizes all the information that the voter needs to make her decision. So that would be the composition of the Senate, that is how many Democrats there are in the Senate, how many Republicans, because remember, not all of those seats are up for election. There's the party of the president, the sitting president, or the incumbent president. The voter has to know whether the current president is term limited, is this his 2nd term? He also has to know whether it's a midterm election. If it's a midterm election, he's not going to vote for the president, obviously. So that's what's in an electoral state. The voter...
And the current status quo, presumably.
Yes. Well, that's not in there. We separate the status quo.
But how do you know whom you want to vote for unless you know what they're going to be considering?
The state variables that we consider are, for the voter, it's the it's actually the policy chosen in the previous period and the current electoral state.
Oh, I see. So,
Okay.
okay.
So X is chosen here, and now here's an election, and then there's an electoral state, and the voter uses this information and makes
Okay.
essentially is choosing whether she wants, Republican control of the House or Senate or the presidency if it's not a midterm election. The voter is going to, in equilibrium, they're far-sighted, so they are calculating the continuation values of having different compositions of government. And then we also add an action-specific shock to the voter. So the voter might say, I want to vote for Republicans in the House, Democrats in the Senate, and if it's a presidential term, maybe a presidential election, he might vote for the Republican incumbent or something. Okay, we're going to have action-specific shocks added to the voter's payoffs from these actions, right? So if he chooses to vote in this way, he'll get some action-specific shock. We call this vector of votes for the voter, A, for action. So he'll get some action-specific shock plus the continuation value of having that composition, essentially. Okay? So the voter does this, and then that determines the political state for the current period, and then and this X determines the status quo, and then these together determine a new policy for the next period. Okay, so this is all a little bit complicated, and I'm going to just kind of rush through it. But I say a political state here is realized. Office holders are realized because some office holders will leave office, and some will stay. And status quo is realized. We actually allow for there to be some noise on this, right? There's a policy chosen in this period, and then maybe there's some noise, so it moves around a bit, okay? It determines the status quo for the next period. We assume that there are some preference shocks on the payoffs of the politicians, and those are publicly observed. And then finally, we'll draw a legislator to make a proposal in this policy space. Let's say he proposes Y. Then there's a vote on this policy proposal. If the proposal gets a majority support in each chamber and the approval of the president, then that's the policy outcome for the current period. If it doesn't get the approval of the president, then it would require 2/3 majority in both houses to pass, and then become the current policy. And if it doesn't pass, then we keep the status quo. Okay, so that's really a quick description of the model.
The proposer can be from either house?
Yes. Payoffs, I already mentioned a little bit about. So the voters, so these are the staged payoffs of the players. So in a period where the voter takes an action A, he gets this action-specific payoff shock. And if the policy outcome is X, he gets some utility from that. A politician who's in office gets some benefit of being in office, plus some stage utility from X, plus this extra noise term. Okay. And non-elected politicians, they just get their utility from the policy. Okay. Those are the stage utilities, but in equilibrium, these players are forward-looking, so they're discounting these into the future, according to delta. And as I said before, we're looking for equilibrium strategies, stationary strategies. So what does that mean? That means a voter is conditioning on the electoral state, the previous the policy outcome in the previous period, and her action-specific shocks that she receives, and then she votes. An elected legislator, her proposal strategy is going to depend on the current political state, the current status quo, and then her preference shock and the preference shock of all the other elected politicians. And then, as a function of those things, she's going to propose some policy outcome. And then once there's a proposal on the floor, then politicians have to decide how to vote. So we call that an approval strategy. That's going to depend, of course, on the current political state, current status quo, the politician's own shock, and the policy that's proposed. Okay. All right. So in equilibrium, we're looking at stationary Markov-Perk equilibrium in this model, and it's defined by 3 optimality conditions that are pretty straightforward. There's no reason to go through these in detail, but as I said, everyone's forward-looking, and so we're just going to require that, based on their information, the agents are all choosing optimally. Okay. And then this is the only theorem I have for you, and it's not actually a very good deal. It's just assuming that the noise in the model has finite expectation, an equilibrium exists. In fact, it's in pure strategies because of the noise in the model. So you might think that it is an unusual thing, right? But in this model, because of the noise, if you think about the voter, she's only going to be indifferent between voting in different ways for a measure 0 set of action-specific shocks. And also politicians, when they're proposing policy and voting, indifference is only possible for a measure 0 set of shocks. So that's how you get pure strategies out of this. Okay. So there is an equilibrium. Unfortunately, there could be more than one. We don't have any kind of uniqueness result. And, a weakness of this approach, but I think it's tough to deal with in an applied setting, is the multiple equilibrium problem. And we're not really solving that. What we're doing is we're going to estimate the parameters of this problem by just basically computing a single equilibrium for each parameter setting, and we can't really say that that's the only equilibrium, and there's nothing. We don't really know what to do about that. So, okay. So we're actually we're looking at data from 1952 to 2006. Let me just show you the data. So in each year, we can directly observe whether the president is a Republican or Democrat in his first or second term, and we can observe whether there's a Republican majority in the Senate or a Democratic majority, and then in some cases there's a supermajority.
So what?
Supermajority, 2/3 majority. That's been a pretty rare thing. So that's kind of the data that we're looking at. Now, there are some interesting patterns in the data. So you can see a lot of split ticket voting where the Democrats will control one house and the Republicans another. Oftentimes the president will be one party, but at least one chamber will be controlled by the other party. This happens a lot. I don't know if you noticed, but if you look at these columns here, the Democrats have done incredibly well historically. It's only really recently that the Republicans have made any inroads into the legislative branches, but historically the Democrats have been very strong, whereas in presidential races the Republicans have done fairly well. There's also a lot of serial correlation here, right? So, when you, well, not here so much, but like when the Republicans take over, they stay in power for a while, right? So those are some interesting aspects of the data. And actually that serial correlation is kind of interesting because you actually need a dynamic model to explain that kind of thing. And our story for that is that once a party is in power, they're able to position the status quo in a way that, gives the voters incentives to re-elect them. So it's a status quo story rather than an informational story. Okay. So what we're going to do is we will, for each vector of parameters, we'll compute an equilibrium, and then we'll compute the likelihood of the observed data, and we'll just do a maximum likelihood to estimate the parameters that are generating the data. And once we have that, you can imagine doing all kinds of institutional experiments. So the model that we actually estimate, we have to put a lot of structure on this, is, as I mentioned, it's a two-dimensional space. It's actually a grid, 7 by 5. Each dot here then is a point in this policy space. Remember, we don't actually observe policies, so this is a modeling construct. And we can't have 100 senators and 435 representatives. So we're going to kind of imagine composite senators and composite congressmen. We're just going to have a 9-member Senate and a 9-member House of Representatives. But that's enough to allow us to distinguish majority from supermajority. Right? So, in fact, so we're going to have 9 members in each chamber, and let's think of this as being the number of Democrats. Right? So if there are 6 Democrats, then they have an override majority. They have 2/3 of the House of the chamber. If there are 3 Democrats, then the Republicans have an override majority. And in fact, we're just going to keep track of which of these 4 states we're in. So either the Democrats have a majority or a supermajority, or the Republicans have a majority or a supermajority. So that's how we're going to code these legislative outcomes. We'll assume quadratic utilities. And actually, now, I mean, we need to put a lot of structure on this to be able to do anything. And so we're going to assume that all Democratic legislators have the same underlying ideal point. We'll put that right here. All Republican legislators have the same underlying ideal point. We'll put that right here. And then what we're going to do is, as I mentioned before, that in each period, each politician is going to get some preference shock, which is essentially moving his ideal point around in this space, which gives us some heterogeneity in preferences of these politicians. We're going to put the voter, we're going to just assume is somewhere between the Democratic and Republican Party on this horizontal dimension. Maybe he's here. And then the presidential politicians will have ideal points somewhere between their respective legislative ideal points and the voter. Okay, so we're imposing that structure. So sort of from an ex ante point of view, all Democratic legislators have the same underlying ideal point. But remember, because of the noise, when the game is actually played, these guys are going to be heterogeneous. These guys will have different preferences. And that's basically just to save us on computation. It cuts down the number of continuation values we have to compute. Okay, so we'll just assume preference shocks on the politicians are uniform in some square, basically. And I mentioned that we'll be building in some noise in the status quo. So if X is the policy today, then the status quo tomorrow is going to be some random draw from the adjacent points around X. Okay, so that's all set up. We'll assume that the noise on the voter's action-specific payoff is distributed according to extreme value distribution. And then we can calculate a likelihood function, which is pretty ugly, right? So the only thing I wanted to say here, I'm not going to go through all the notation, but in an ideal world, well, what do we actually observe? We observe the electoral states and the political states, and we observe the voters' action. We can see which parties are winning the presidency and the two branches of the legislature, but we don't actually observe the policy outcomes. Ideally, we could see the policy outcomes as well. And then if we saw all of this, then we could compute a likelihood, right? So given a vector of parameters, we can compute an equilibrium, and then we can calculate the likelihood of observing that data. Since we don't actually observe the x's, we basically integrate them out, and we have kind of an aggregate likelihood. And that's what we're going to maximize. Okay. So what we're going to try to estimate are the following things. I'm going to sort of ignore these for now. We're going to estimate the discount factor of the players. We're going to estimate the location of the voter. We're going to estimate the location of the presidents, and we'll estimate the value of office. These are all things we can't observe. We'll actually estimate a parameter that kind of determines the degree of majority party agenda control as well. So, and a dispersion parameter for the voter's preference shock. Okay, so what we've done so far is not a very serious maximum likelihood because what we've done so far is we've just put a very coarse grid on this parameter space to get an idea of what things look like. And here's what we get. And so just to give you an idea, I mean, we looked at 4 possible values of the discount factor, 0, 0.25, 0.5, and 0.75. And you know, our maximum likelihood estimate is that these players are forward-looking. They actually put quite a bit of weight on the future. The office benefit is actually quite high. This actually means that the presidential politician's ideal points are right at the voter. So at least the way our model is rationalizing the data, it looks like presidential politicians end up competing and land right on the voter. And the voter's ideal point is over to the left, favoring the Democrats, which is kind of, we think what's going on is that's how the model is explaining the success of the Democratic Party in the legislative races. This doesn't mean much to you, but it means that the dispersion on the voters' preference shock is very small, which is a good thing. It means that we don't need a lot of noise on the voter to rationalize the data. And I'm not even going to focus on those. So what do we get from this? We see a pro-Democratic Party bias because the voter seems to be located more toward the Democratic Party. Presidents are located at the median. The likelihood ratio test actually allows us to reject the model where delta is 0. So what that tells us is that to rationalize the data, you actually do need to think about forward, 5 minutes. You do need to think about forward-looking players, and that dynamics are actually important, and which we think is all very interesting. So to give you an idea of what the better idea of the empirical results, I mean, there's a lot of ways you can cut the data, but one way to do it is to look at for example, we can look at the distribution of, so given an equilibrium for the MLE estimates, we can compute the invariant distribution over types of government, for example. Okay, so according to that invariant distribution, in the first half of a president's term, 43% of the time, we have a Republican president and divided government. 21% of the time we have a Democratic president and unified government. Okay, so you can compute these sort of long-run probabilities, and then you can compare those to the data. This is completely ocular, obviously. But if you just compare these numbers, I mean, it seems like we're doing a pretty good job. We're the empirical mode here is also the estimated mode, which at least we're hitting that right. And we also are able to do that over here. So we're kind of getting something that looks reasonable there. As well, we can look at the long-run invariant distribution over voter choices. This is midterm elections, so the voter is only voting for Republicans voting for the Senate or the House. And you know, again, the estimated mode is the same as the empirical mode, and the distribution seems not too bad. And we can continue to cut the data. Here I'm looking at long-run distributions. We can take a closer look at the dynamics, and again, the model seems to be doing pretty well just based on visual inspection. So I don't think I have enough time for that stuff. And I basically just said that. So let me get to the end. So what we're doing here is we're starting a research program, and it looks different than a lot of the mechanism design that you guys are seeing, in the usual literature and from the other speakers at the conference. But to us, it seems like the way to go if you actually want to do applied political mechanism design. What we need to do is do a more serious maximum likelihood, because the numbers I gave you were really just maximizing over a very coarse grid. So we need to do something like a Nelder-Mead algorithm to optimize over the continuum. And once we've done that, I mean, we need to be more serious about exploring the equilibrium strategies these guys are using and to understand the dynamic incentives in the model. And then obviously there's the institutional experiments, which we haven't done yet. And it's always nice to end with a wish list. I mean, this is as I mentioned, it's a fairly simplified model in some ways, and there's a ton of ways you could think about extending this and different questions to ask. I mean, we've completely abstracted from pork barrel politics, different levels of government. There's no judicial branch. What effect does having a judicial branch have? We talked a little about the Electoral College today. This is a big question, especially in the U.S. What would be the impact of using direct elections instead? Another big picture question is, parliamentary democracy versus Republican government. And the last thing I'll mention is, I don't see MRIs fitting into this, but you could imagine, taking this approach to the lab and let people play a government for some long period of time and see really how this approach works with real people. So that's all.
Thank you. Some questions.
So, again, the same question. So, one part of the model is anti-delta, so you try to mimic the real structure of the authorities accurately, but then you make quite accurate assumptions about how the aspects say to utility, right?
Yeah, and distribution of noise.
Think that these accurate assumptions do not blow away the anti-delta part.
Well, you need to make these assumptions to identify the model, and I think I'll answer. I'll answer. I mean, first of all, I think that they're specialized assumptions, right? From a theoretical point of view, I'd rather not make those assumptions, and in other work we haven't made those assumptions. But to get anywhere we need to, and I guess what makes me think that? Well, there's two answers. One is if the model explains the data very well, and that's somewhat reassuring. But again, this is structural estimation. And if we're doing this for the purposes of doing institutional experiments, you want to make sure that those estimates didn't rely on the structure that you were imposing before. And, that last throwaway line there, I guess, is my answer to this. I mean, how can you really be assured that, that these functional form restrictions aren't driving the estimates? Well, you can, in an experimental setting, you can actually see whether they do make a difference. If it did make a big difference in an experimental setting, then I'd be worried about taking this to the real world and, proposing a constitution for Iraq or something.
All right, that's another way. Did you try simpler model than, say, the high fidelity one we had?
No, not. I mean, it's pretty simple in some ways. I guess one way it could be simpler would be just to use one dimension instead of two, for example. We haven't done that, and I think. I mean, one thing that we can do with this approach is actually, we can check to see whether having two dimensions actually makes a big difference. Maybe one dimension really is just fine. So, we haven't done a lot of those checks yet. Yeah.
Yes, I was wondering why did you go ahead with random shape of action rather than having voters on the ideological spectrum where you can, for simplicity, just divide this spectrum between left and right, and in the middle the swing voter that utility is 0, for instance, and then be able to compute exactly what's equilibrium depending on the ideological spectrum.
Well, I'm not sure I got all.
With this random action that we have in here, where the voter can vote today Republican, tomorrow Democrat, and the next day Republican, we're going to have a lot of multiple equilibrium, which will be very difficult to just design.
Well, so remember that. Where was this? I was coming up here, right? Here. So the voter does have an ideal point in this space. So he's not just like randomly deciding whether he likes the Democrats or Republicans. He has some ideal point. We actually estimate this to be, on our grid, it's negative 0.375, and he's calculating the continuation value of having, Democratic control of the House versus Republicans. And so he's calculating the continuation values of these things using this stage utility, and then we're adding this noise on top of it, right? And so you're suggesting, what's the alternative?
No, I thought that for simplicity it was going to be easier for just having a spectrum where you can just use the value of the voter from the left and the value from the right, rather than having a random action of a voter, just a randomizing action.
Using a voter on the left and the right, is that what you said? Well, that would mean there are two voters, which I have to tell you, I mean, I gave Tassos credit for the computational aspect of this project, which is a big chunk of it, and right now we're doing all of this running MATLAB on an 8-core Mac, and we're able to compute these things in reasonable time. But if you start, adding more voters and whatnot, it just there's this curse of dimensionality, and the computational cost just shoots up. So right now we're facing all these constraints, so computation is one of them, and so we wanted to find a high fidelity model, but subject to being able to compute equilibrium and all that. So one of the concessions we made, and hopefully we can improve this in the future, but one of the concessions we made now is we just wanted to deal with a single voter, and obviously this goes back to Igor's question. I mean, that might be a good model for rationalizing the historical data, but if you're considering institutional changes, who's to say that those parameter estimates weren't sort of specific to this institution? So, so it's a concession we've made. So I guess the short answer is because we wanted to have a unitary single voter.
So you possibly running experiments to test your model. One thing that I guess is interesting is your model requires that people do the level of foresight and sort of memory that people actually have compared to the what the model claimed that they have. And I guess you can perhaps run some experiments that would like to estimate some of these parameters.
Well,
how does this?
I mean, the model allows for delta to be equal to 0, so people could be totally myopic, but it turns out when you do the maximum likelihood that that doesn't explain the data that well. You explain the data better with a rather high discount factor. So that's an empirical finding. But it's assuming that in the historical data you're observing is generated by this equilibrium play, and that's where taking this to a lab setting could be useful, because then you know what the actual parameters are, and you can actually see whether they're playing the way they're supposed to be playing.
I had a question about the value of being in political office, which, if I recall, turned out to be quite significant. And this is met in your model. This arises because people will vote, legislatures will vote, or presidents will vote in a way that keeps them in office, but which is at odds with their political position. I was wondering what the mechanics of generating a positive benefit to being in office were in the model.
Right. So and again, we need to sort of explore these equilibrium strategies that we're computing more thoroughly. But the idea is that you could, as an elected politician, have some influence on where policy is set and on tomorrow's status quo, and you can use that influence to improve your prospects of being reelected. And what we're finding is that these elected legislators, they're willing to take some hit in terms of their policy utility, right, in order to ensure reelection. Yeah. I wish I could tell you more about the form of those incentives. I mean, we know that they're there from the estimation results, but we haven't really explored the structure of these equilibrium strategies to tell you exactly what that incentive is. Does this mean that are they pushing policies to be more extreme than they otherwise would because of this reelection incentive, or are they pushing policies to be more moderate? And we don't know what's going on yet.
What about policies that are considered but never even come to a vote? So, for example, a big item that Bush had in his second term was privatizing Social Security. It died in committee. It would never appear in your model, presumably.
Well, of course, policies. So here we have one policy choice every 2 years, basically, right? So one period in this model is 2 years, and obviously there's more than one vote in every 2-year period. Right. So I mentioned that this policy space, it's a mathematical construct, and so we're kind of collapsing all policy decisions into this single decision, single choice of this two-dimensional policy, and so that sort of thing just doesn't really, our model doesn't say anything about that kind of thing, about a decision, a policy proposal that just doesn't come to the floor. It's,
But in a way, you might be you were suggesting that presidents are hitting the political median spot on, but by ignoring the attempts of presidents to do rather extreme things, which never get it, but which never get anywhere. You might be overstating their moderation.
Yeah, I mean, one thing I should clarify is that I had to go through it so fast, but that convergence to the voter, that's this underlying ideal point. But remember, there's noise, there are preference shocks in the model too.
Yeah.
So it certainly can be that you have a president who draws a preference shock that's way over, far away. Yeah, I mean, that kind of data, it's difficult to quantify, I guess. I mean, it would be nice to have, the more data, the better, right? But it's all about trade-offs.
It could be the reverse also, right, in this case. That, Bush had suggested that for political reasons, but he knew that it was going to die, and he really wanted to reposition relatively to the median, and so the policy he actually
Yes.
chose.
Yeah. Well, on the issue of gay marriage, that there's quite a lot of evidence to suggest that
Right.
he proposed gay marriage, a ban on gay marriage, knowing that it would never get through. Exactly.
Maybe I shouldn't even say this, but I have to admit that in this model, we're actually assuming that proposals come from legislators, and we don't even allow.
Yeah, I wanted to ask you about that. Why don't you allow it?
In fact, I think that we should allow it, and we should estimate that. And see, does the data suggest that proposals come from the executive branch? I think we should do that. Yeah. There's one more question. I don't know if there's time, Eric. Though.
We're actually over
All
the
right.
question period, but
Sure. We can talk later.
so perhaps we should move on. But thanks a lot, John.
Sure.